Follow me, let me explain what the phenomenon isotopy is all about. I will also explain what an isotope is all about and the calculations that we can make using the phenomenon. Follow me, let's go. All right, the topic we have today, of course, is in chemistry. That is the topic we call what? Isotopy. When you hear isotopy, what does it mean? Isotopy simply means the phenomenon, that is, the situation whereby atoms of the same element will have the same atomic number but different atomic masses. Atoms of the same element, they will have the same atomic number but different atomic masses. That's phenomenon, we call it what? Isotopy. All right. Assuming that we are talking about this element X, you notice that this element X, it will have some atoms. Let's assume that it will have two atoms. Remember here, we write atomic number here. So assuming that the atomic number here is A, atomic number here will also be what? A. Can you see that? All right, they will have the same atomic numbers, but you notice that atomic mass is here. Let's assume that this one is K, this one will become what? This one will become P. They will now become what? Different. The same element, XX, they have the same atomic number. Can you see? AA, but different what? Atomic masses. All right, so when you have something like this, we call it what? Isotopy. We call it what? Isotopy. Can you see it? Isotopy, that is the phenomenon. We call this one isotopy. Existence of atoms of the same element that will have the same atomic numbers but different atomic masses. All right. So the question now is this: why will these atoms now have different atomic masses? Why? Since they are the same element, atoms of the same element, and because that they are atoms of the same element, that's why they have the same atomic numbers. Atomic numbers will never change. If atomic numbers change, that means that they are no longer the same element. So because that they are the same element, that's why they retain their what? Atomic numbers. Okay. So, but this difference in atomic masses is as a result of what? It's as a result of difference in their what? Neutron numbers, number of neutrons that they contain. As we know that atomic number simply means what? It simply means what? Number of what? Number of protons contained in that what? That atom. The number of protons contained in that atom is what we call what? Atomic what? Numbers. But when we talk of atomic mass, we have atomic mass like this. Atomic mass is equals to have number of protons plus we have number of what? Neutron. Can you see that? Number of proton plus what? Number of what? Neutrons. That is what will give us what? Atomic mass. Can you see that? Atomic number will give us this. Atomic mass will give us what? That. All right. Now they have said we are talking about the same element, which is what? XX. Two different atoms of the same element. So now we have said that they have the same atomic number. That means that the number of protons will be what? The same. Can you see that? So the difference you are going to see is as a result of what? The number of neutrons, because atomic mass is equals to proton number plus what? Neutron number. Now if you have proton number to be equal, that means that any variation that you are going to have should be as a result of what? Neutron numbers, because they now have what? Different neutron numbers. All right. So isotopy is as a result of what? Difference. It's as a result of difference in neutron number. It's as a result of difference in what? Neutron numbers. Can you see that? So if there is no difference in neutron numbers, there will be no isotopy. Is it clear? if there is no difference in neutron numbers, there should be no what? Isotopy. Is it clear? So we have isotopy as a result of difference in the neutron number of this particular atom from this particular atom, because we already have that their proton numbers, they are what? Equal. All right. So that is it. Okay, so we have again what we call what? Isotope. Isotope. Remember, we said isotopy. Now we now said what? Isotope. We have the one we call isotope. So isotope, they are those let me call isotopes. Isotopes are those atoms. Isotopes are those atoms that experience the phenomenon we call what? Isotopy. Like here now, these two are called what? Isotopes. These two are called isotopes. They are those atoms of the same element that have similar atomic number but different atomic masses. They are those atoms of the same element that have similar atomic number but different atomic masses. So any two or more atoms of the same element that will experience isotopy, we call them what? Isotopes. We call them what? Isotopes. All right. So like here now, this and this, they are said to be what? Isotopes. So the atoms that we experience this isotopy, that's what we refer to as what? We refer to it as what? Isotopes. All right. So remember what I said, that an isotope, can you see that? Or let me say isotopes. Remember what I said earlier. Isotopes, they have similar atomic numbers, but different atomic masses. Can you see that? Due to difference in their neutron numbers. Due to difference in their what? Neutron numbers. So isotopes, they have what? Similar atomic numbers but different atomic masses due to difference in their what? Neutron numbers. There are some known elements that can exhibit isotopes. We have chlorine. Chlorine can do that. We have chlorine. Chlorine can exhibit isotopy. All right. Apart from chlorine, we still have some other elements that can exhibit what? Isotopy. Okay. So remember, in conclusion, is that isotopy is the phenomenon whereby two or more atoms of an element will have similar atomic number but different atomic masses. That phenomenon or that situation is what we call what? Isotopy. Then those atoms of the same element that will have similar atomic number but different atomic masses, they are referred to as what? Isotopes of that element. They are referred to as what? Isotopes of what? That element. All right. So I said again that the difference in their atomic masses is as a result of what? Difference in their neutron numbers. Their proton numbers will remain the same, but there should be difference in their what? Neutron numbers, and that's why you now have difference in their what? Atomic masses, because atomic mass is the sum of what? Proton number and what? Neutron number. So if the proton number of this and that will remain the same thing, and you now say that atomic masses are different. That means that the difference will come from where? The neutron number that you are going to add to proton number in order to get what? The atomic masses. Is it clear? So the difference in the atomic masses is as a result of what? Difference in their what? Neutron number. All right. I said again that example of an element that can exhibit this isotopy is what? Is chlorine. We still have some other elements that can exhibit it. All right.